Hey students, welcome to Mathgotserved.com. In this clip, we're going to be going over problems 11 to 15 of the January 2017 Geometry Common Core examination. Alright, let's take a look at question 11. It reads, a solid metal prism has a rectangular base with sides of 4 inches and 6 inches and a height of 4 inches. A hole in the shape of a cylinder with a radius of 1 inch is drilled through the entire length of the rectangular prism. Question: what is the approximate volume of the remaining solid in cubic inches? Okay, so we have the figure provided for us here. Let's go ahead and write down the formulas that we're going to use to determine the volume of the resulting hollow rectangular or square prism when a cylinder is drilled out of it. Okay, so let's write down the formulas. There are 3 formulas we're going to be looking at here. Okay, so the first one is for the volume of a square prism. Okay, volume of a square prism. Volume of a square prism is going to be given by the area of the base, big B, times the height. The area of the base, since it's a square, we can call this S, and S is going to be the area of the base, S squared, times the height, H. Formula number 2 is the volume of a circular cylinder. Okay, so volume of a circular cylinder, or just a cylinder, or a circular prism. Okay, so it's going to be, the volume is going to be area of the base times height, and the area of the base of the cylinder is a circle, so the area of a circle is pi r squared, and then we just multiply that by the height. Lastly, we need the area of the volume of the hollow prism. Okay, volume of a hollow prism. The hollow prism we're talking about here is the one where the cylinder is taken out of the square prism. Okay, so in that case, we're going to have the volume. The resultant volume is going to be the volume of the square prism. You take away the volume of the cylinder. Volume of the cylinder. Okay, so let's go ahead and do it. Oh, wait a minute. The formula is going to be just the difference between these two, right? So S squared H is the volume of the square prism minus the volume of the cylinder, pi r squared H. Okay, so we need the side length of the square, the height of the prism, which is equal to the height of the cylinder, and the radius. So let's list those. S is 4. That's the square base. This area, entire region right here is the base, and this is the height. Okay, so S is 4. The radius is 1, and the height of the hollow cylinder, the hollow prism, is going to be 6 inches long. Okay, so the volume of our hollow prism is going to be S squared H minus pi r squared H. Plug that into your calculator. Well, let's substitute the values first. So S is 4 squared times the height. The height is 6 minus pi times the radius is 1 times the height, which is 6. Okay. All right, let's input that into our calculator. So we have 16 times 6 minus 6 pi. Okay, and then we get 77.15. We are asked to round to, let me see, where are we rounding to here? Well, we're rounding to the nearest whole number. We're rounding to the ones place. So we can simply round it up, is approximately 77. As we can see in the calculator, our answer is option number 2. Alright, for number 12 it says, given the right triangle on the diagram below, what is the value of x to the nearest foot? So we have a right triangle relating the measure of an angle to two sides. So anytime you have a scenario like this, the formula that you're going to use is captured by this acronym SOHCAHTOA. Okay, SOHCAHTOA, we know what that is. So which of the three functions, trig ratios, are we going to use? Sine, cosine, or tangent? Alright, so let's take a look at the triangle. This is the angle under consideration. So based off of this angle, we know that this side is going to be the opposite. The longest side opposite the 90-degree angle is the hypotenuse, and adjacent is the third side. Now, the side I know is the adjacent. The side I need is the hypotenuse. Okay, so I don't know the opposite, I don't need it, so we scratch it out. Now, which trig ratio has adjacent and hypotenuse in it? Sine, cosine, or tangent? We can clearly see that the applicable trig function here is the cosine function. So cosine of theta is adjacent divided by hypotenuse. Okay, let's apply it here. Theta is 40 degrees. Okay, so theta is 40 degrees, as you can clearly see. The adjacent is 14, and your hypotenuse is x. So using this ratio, we have cosine of 40 is equal to the adjacent divided by hypotenuse. We now multiply both sides by x. The reason being that we don't want the variable we are solving for in the denominator position. So when we multiply both sides by x, you have x cosine 40. Now, x is no longer in the denominator position. We now divide both sides by cosine 40. Divide by cosine 40, divide by cosine 40. That cancels out. And then you have x equals, let's input this into our calculators. We are looking at the ratio between 14 and cosine 40. And we have 18.275. We're rounding it to the nearest foot, so it's going to be 18 feet. Answer for question number 12 is option number 3. Alright, let's take a look at question 13. In this question, we're dealing with the dilation of a line segment about a point that is not the origin. Okay? So it reads, on the graph below, point A, 3, 4, and segment BC with coordinates 4, 3, and C, 2, 1 are graphed. So we have it here, the point and segment BC. Question, what are the coordinates of B prime and C prime after segment BC undergoes a dilation centered at point A with a scale factor of 2? Alright, so there are two ways we can solve this problem. We can do it graphically, and we can do it arithmetically, okay? I will show you both ways of doing it, and then on the exam you can pick whichever method you like to solve this problem. Let's start with the easier one, which is a graphical approach. So what we're going to do is we're trying to dilate this segment about this point right here, okay? The goal is to cause the resultant figure to be twice as long as this. So all we need to do is basically look at the growth triangle, okay, the slope triangle to be specific. For AB, you fall 1 and you run 1, okay? From A to C, you fall 3 and you run 1. All you simply have to do is double these growth triangles or slope triangles, and you end up with the endpoints of the segment C prime, B prime. Okay? Alright, so let's start with AB. From A to B, you go down 1 and over 1. So if you want to get to B prime, guess what? You go down 2 and over 2. This point right here, let me switch my colors. This point right here is going to be point B prime. Okay, dilation by a scale factor of 2, you're dilating this point from this point in such a way that it's going to be twice as long. Okay, so that takes you right there. So A straight through B, that's B prime. Now where is C prime going to be? Before we do that, let's write down the coordinates of B prime. So it's going to be 1, 2, 3, 4, 5, 5, comma 2. So for C prime, you go down 3 and over 1 to get to C. So if you want to get to C prime, you do double that. Okay, so instead of going down 3, you go down 6. So 1, 2, 3, 4, 5, 6. You go down 6. And then instead of going over 1 to get to C, for C prime, you go twice as long, 1, 2. That will take you right there to C prime. And you see the dilation here of this segment through C by a factor of 2 takes you to C prime. Okay, so the segment that we are looking for, segment C prime B prime, is defined by this segment right here. Coordinates of point C prime is, let's see, 1, comma negative 2. And as you can see, our answer is option number 1. Okay, so let's say we don't have a graph or we want to do this using arithmetic. Let me show you the formula that you can use to accomplish the same result. Okay, so formula for dilation. So if we have a point, let's say we have the point AB. Okay, so let's call it P. If point P, which is AB, if it is dilated at a point dilated centered at a point xy with a scale factor k, then the resulting point P prime is going to be given by, you do the x's first, okay? So for the x's, you do scale factor k times a minus x plus x. And then for b, you do the scale factor k times b minus y plus y. Alrighty? So let's go ahead and do it. Our xy will remain the same. So x comma y is going to be the point that the dilation is centered about, which is basically point A, and that is 3. Wait a minute. So AB, xy is going to be 1, 2, 3, 4. Okay, now let's start with point B. We want to dilate point B to get B prime. So to get B prime, we'll start by writing down what point B is. So point B is 4, 3. So that tells us that this is going to be our A and B. Okay? So B prime, we're dilating 4, 3 by a factor of 2. So K is 2 centered at 3, 4. So applying this formula that we have up here, we have the scale factor K, which is 2 times A minus X. So 4 minus 3 plus X plus 3. And then for the y coordinate, the k again times a minus the y. So it's 3 minus y, 4 plus y. Okay, now we'll just use the order of operations to simplify this. So we have 2 times 4 minus 3 is 1 plus 3, comma 2 times 3 minus 4 is negative 1 plus 4. Simplify that. We have 2 times 1 is 2 plus 3 is 5. And then 2 times negative 1 is negative 2 plus 4 is 2. So B prime is 5, 2, as you can see here. Now let's do the next point C prime. So first of all, let's indicate where we are starting from. Point C. C is 2, 1. So this is going to be our A and B for the formula. C prime, using the formula, is K. Scale factor is 2 times A minus X. So it's going to be 2 minus 3 plus X plus 3. That's for the X coordinate. For the Y coordinate, we have K again times B, which is 1 minus Y, which is 4 plus Y. Okay, just following these formulas here. And let's use the order of operations to simplify this, okay? So we have 2 times 2 minus 3 is negative 1 plus 3, comma 2 negative 1 times 1 minus 4 is negative 3 plus 4. Okay, now simplifying further, we have negative 2 plus 3, comma negative 6 plus 4. Final answer is going to be 1, comma negative 2 for C prime. And we see that these two results we got with our arithmetic approach matches what we have here when we did it graphically. So we have confirmation that the answer to question 13 is option number 1. All right, let's take a look at question 14. It says in the diagram of right triangle ADE below, BC is parallel to DE. Which ratio is always equivalent to sine A? Okay, so now again we are relating the measure of a side, the measure of an angle to two sides. Okay, so this is A right here. So whenever we're doing that, we have a right triangle, and we want to relate the measures of two sides to an angle. We're going to use the formula that's captured by the acronym SOHCAHTOA. In this particular problem, sine is clearly specified for us, so we're going to be using the ratio sine theta equals opposite over hypotenuse. Okay, since we have two triangles here, we're going to have two opposites to hypotenuse and two adjacents. We will focus on the smaller triangle first. So for the smaller triangle, this is going to be the opposite. Okay, and since we're dealing with sine, we care about opposite and the hypotenuse because this will be 90 degrees also. Okay, how do we know that this is 90 degrees? If you have two parallel lines and a transversal, these two are corresponding angles. Okay, so they are congruent. Okay, all right, let's go ahead and write that down. If BC is parallel to DE, then angle BCA and angle DEC are corresponding angles, which implies that what? Implies that they are congruent. Alright, so we can easily know that angle BCA is 90 degrees also. Okay? Alright, so we have that taken care of. Now let's go ahead and set up our trig ratio. So for sine A is going to be what? Sine A is going to be opposite BC over hypotenuse, which is AB. Okay, let's look at the options here. We have sine A, BC over AB. Our answer for question number 14 is option number 3. All right, let's take a look at question number 15. It reads, in circle O, secants ADB and AEC are drawn from external point A such that DBE and C are on circle O. If AD is 8, AE is 6, and EC is 12 more than BE, the length of segment BD is... All right, so let's take a look at the formula that's going to be guiding us through this process. So let's say you have a circle, and you have two secants with a common exterior point A. So this is the first secant right there, and you have another secant, and we have the exterior point A and this secant line ADB, and then the other secant is AEC. Okay, now what formula can we use to relate the different measures? Let's call this little a and call this B. Let's call this side here C and call this exterior side here D. So the formula that we're going to be using for the secants is the sum of the length of the first secant A plus B times the length of the exterior portion of the secant B is equal to the length of the second secant C plus D. Okay, C plus D is the entire length times the exterior part of the secant D. Alright, so that's basically what we're going to be using to solve this problem. Now let's use the information that we're given to populate our unknowns and determine what the desired variable is. AD, which is little b, is 8 units long. AE is 6 units long. EC is 12 more than BD. Okay, so let BD stay as BD. BD is 8. Leave it alone. EC is 12 more than it, so C is going to be 12 plus BD, which is A. So 12 plus A. All right, so with this setup, we can set up an equation with one unknown to figure out what the measure of BD is, and the measure of BD is basically A. So setting up our, let me rewrite the formula again. So we have A plus B times B is equal to A plus C times, no, it's not A plus C, is equal to D plus C times D. Okay, so is equal to, let's just say C plus D times D. Okay, let's fill it in. So A is just A plus B is 8 times B. B is 8. C is 12. C is actually, yeah, is an expression. So C is 12 plus A. D is 6. So we have 12 plus A plus 6. And D is 6. Okay? So we arrived at this by simply substituting the values here into this formula over here. All right. So let's simplify this. We have 8 here we can distribute. So we have 8a plus 64. Remember, when you have parentheses, you distribute. Okay. And then on the right side, we have to simplify this interior portion first before we distribute. So we have to combine 12 and 6 to yield 18. So 12 plus 6 is 18, and then you have a plus 18 multiplied by 6. Now we can distribute the 6 to the 18 and the a. Okay? All right, when we do that, we have 8a plus 64 equals 6a When you add 18 and when you multiply 18 and 6, that's 60 plus 48, 108. Subtract 6a from both sides, and you can also subtract 64. While you're at it, the goal is to get the variable on one side of the equation. Remember, solving algebraic equations with variables on both sides in Algebra 1, that's what we're doing here. Okay, so you subtract, you have 2a equals, this adds up to 0. 108 minus 64 is 44. Divide both sides by 2, and your final answer, a, is 22. Okay, so if you go back to the figure, a is db or bd, so the length of segment BD is equal to 22. Answer for number 15 is clearly option number 2. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this tutorial or any math concepts on the Regents exam in general, just ask your question in the comment section below. Don't forget to subscribe to our channel for updates to other cool math tutorials such as this. For more tools, tips, tricks, and formulas to help you pass the Regents exam, do visit our website at mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.